Hi everyone. We're starting a new module today, Module 3, and what we're going to talk about is what it means for polygons to be similar. So let's talk about that word. Now, let's start with congruent. We said two shapes are congruent if they are exactly the same. Well, we say shapes are similar if they have the exact same shape, but they could possibly be different sizes. It's like when you have a bigger and a smaller version of the exact same thing, we call them similar. Now the symbol for similar is a little squiggle. It's like what goes over the equal sign on congruent, but without the equal sign under it. So let's say, for example, that these two triangles are similar. Let's say we measured them out and they are exactly the same thing, but the one on the right is a little bit smaller. Then we could say triangle ABC, that's the one on the left, and then that little squiggle means is similar to triangle DEF. And that's what we call a similarity statement, just like earlier in the year we did congruent statements and had a congruent symbol instead of similar. Okay, so just like with congruent shapes, similar shapes have corresponding parts. And corresponding means matching up, like the same angle from each triangle, or the same side from each triangle. So for example, I just picked one, and I said angle C, which is right here, corresponds to angle F, which is right here. That's basically like the top angle of each of the triangles. Then for another example, I said side AB, which is the bottom right here, corresponds to side DE, which is the bottom of this one. So it just has matching parts, exactly like congruent shapes. Now, one of them is the same and one of them is different. So for our theorems today, let's talk about the angles and the sides of similar shapes. The one that's the same is angles. Corresponding angles are still congruent, just like in congruent shapes. So remember on the last slide, I said angle C and angle F were corresponding angles. That means angle C is congruent to angle F. And then the other ones, I didn't say them before, but I said angle A, or I didn't say, but I could say angle A is congruent to angle D because they're corresponding, and angle B is congruent to angle E because they're corresponding. So, and then I already typed them in here. Angle A is congruent to angle D, that's the one I put 2 arcs on. B is congruent to E, that's the one with 3 marks on it. And angle C is congruent to angle F, that's the one we said on the last slide, and I marked it with 1. So just like with congruent shapes, corresponding angles are congruent in similar shapes. So the angle, and you can tell just by looking, like angle C and angle F is going to be the same angle. But the sides are not congruent. You can tell just by looking, one of them is bigger. Now before we get to that, let's do an example using angles. So let me give you those same two shapes, and I'm going to say that angle A down here is 3x minus 7. And angle D over here is 6x minus 67. And I said we want to figure out what angle A is. And actually, when you're solving for angle A, you're also solving for angle D because they're equal. That's our theorem. They're congruent. And we're going to use that theorem to set it up. So once I realize that angle A and angle D are congruent, that means these two things here are equal. So my equation is going to be 3x minus 7 equals 6x minus 67, and that's the one I'm going to solve for x. So I have x's on both sides. Let's get rid of the smaller one. I'm going to do a minus 3x on each side. Get rid of that one. So I have negative 7 equals, that would be 3x now, and we still have minus 67. So now if I'm solving for that x over on the right, probably the next thing I want to do is a plus 67 to cancel out the minus 67. And that's gone. Negative 7 plus 67 would be 60. So 3x equals 60. Let's squeeze it in here. Last step would be divide by 3 to cancel that out. And what I get, 60 divided by 3 is 20. So I get x equals 20, which is not the answer to the question. Remember, every time you finish a question, every time you think you finish a question like this, go back and look at what I asked you to do. I didn't say solve for x, I said find a. So what I want to do now is take that 20 and plug it in here. So let's do that. Let's take the 3x minus 7 and substitute 20. That would be 3 times 20 minus 7. That would be 60 minus 7. Oops, that's a 7, not a 6. So that would be 53 degrees. Now, a good way to check your work is to plug that 20 in right here also and see if you get the same thing, because we know they're supposed to be equal. And you would. You would have 6 times 20 is 120, and 120 minus 67 gives you 53 again. So now we're real confident in our answer. We know we got the right answer. Okay, so let's go back to those sides. So we started to say that the sides of similar shapes are not congruent. They're not equal. Like if you look at AC and DF, AC is big, DF is small. Now they are not congruent, but what they are is called proportional. And here's what that word means. That means if I take any pair of matching sides, of corresponding sides, and I divide them, you're going to get the same answer every single time. So for example, if I didn't, I wrote it as fractions, but remember, fractions mean divide. So this right here means AC divided by DF. That would be this side right here divided by this side right here. Now whatever it equals. Maybe I divide them and I get 5, just to make up a number. That means when I divide BC by EF, that would be this side here divided by this side here, you're going to get 5 again. And when I do AB divided by DE, that's the bottom divided by the bottom, I get 5 again. And the number might not be 5, it can be anything, but the idea is you're going to get the same number each time. That's why I put the equal signs. So each fraction is always equal. If you take one side of one triangle, divide it by its corresponding side of the other triangle, you'll get the same number for all 3 sides. That's what it means to be proportional. Now the number that you get, remember for my made up example I said maybe it's 5. That's called the constant of proportionality or the scale factor. Either one is fine. Some books call it one, some books call it the other. They both kind of mean the same thing. Now basically what it's telling you is how many times bigger one shape is the other. So like if I'm dividing all sides and I'm getting 5 every time, 5, 5, 5, what I'm really saying is one of the triangles is 5 times bigger than the other. Or if I'm dividing each one and I'm getting 2 each time, then one of the triangles is twice as big. And it doesn't have to be a whole number. You can divide each time and get 1.2, and then what it means is one is 1.2 times bigger. So you can have fractions, you can have decimals, but the idea is you're going to get the same number each time. So let's turn that into our last example for today. I said I want you to solve for x in the similar polygons below. So I'm telling you in the directions that they're similar. And what that means is the sides are proportional. So I can match them up and I can set up a proportion. And we solved proportions way back in Module 1 of Book 1. I'll review that with you in just a minute. But let's set up the proportions first. So as I'm looking at my sides, I'm trying to look for corresponding sides. So I have number 1, I have the 16 and the 12 right here. That's one pair of corresponding sides. And then number 2, I have the 3x plus 11 and the 24. That's another pair of corresponding sides. Now when you just look at the problem, you think, okay, I also have the 20 and the 18. That's a third pair of corresponding sides. But those are actually not corresponding. Because if you look carefully, the 20 corresponds to this blank side right here. I don't have anything to put there. And the 18 corresponds to this blank side. I don't have anything there. So those two numbers are not proportional. We only have 2 that work here. We have the 16 and the 12, that's one pair. And we have the 3x plus 11 and the 24, that's the other pair. So let's just use those 2. We only need 2 to solve for x anyways. So let's do, you remember I presented in the notes as a fraction? Let's do it that way. Let's do the ones I circled in black first and say 16 divided by 12 equals, and then we'll do the ones I did in red. That would be 3x plus 11 over 24. Now, there's one thing you want to do, one thing you want to be careful of when you're doing this. Make sure you go in the same order. Like both of my fractions are the left polygon first over the right polygon second, and that's fine. It also would have worked if I had done both of them right polygon over left polygon, but if you switch them, it doesn't work. Like if I wrote this as 16 over 12 equals 24 over 3x plus 11, I wouldn't get the right answer. So I worked kind of left to right. I did this one over this one equals this one over this one, just to make sure it was right. Okay, so now remember I said we are going to review how to solve a proportion. And a proportion is when you have two fractions equal to each other like this. And there's one thing I probably would do before I start solving this. If I start solving this right now, I have some pretty big numbers in there. But that 16 over 12, that's a fraction. I can't do anything with the 3x plus 11. That's my variable. But 16 over 12 is a fraction, and it can be reduced. So I'm going to reduce that. I'm going to divide both of those numbers by 4. 16 over 12 is the same as 4 over 3. Now, you didn't have to do that. You could have done the question as it was originally written, but see, I have much smaller numbers to deal with now. And the reason that's important, if you remember from way back in Module 1, Book 1, the way you solve a proportion is by cross multiplying. I'm going to do 4 times 24 equals, and then I'm going to do 3 times 3x plus 11. Now see, if I did that on the one above, I have 16 times 24. That's a really big number. I probably need a calculator for that. And then I have 12 times 3x plus 11. I'm getting bigger numbers. So it's a little easier if you reduce first. Now I can do it without reducing though. 4 times 24 would be 96. Do a distributive property on the other side. 3 times 3x is 9x. Plus 3 times 11 is 33. That's the equation I want to solve for x now. So what I would do first, or I've already done some work, what I would do next is probably subtract 33 from both sides to cancel out the plus 33. And I get 63 equals 9x. Divide both sides by 9 to cancel the 9 there. And it looks like our final answer is going to be 63 divided by 9, which would be 7. Now remember, every time I think I'm done, I go back to the directions and I look for what I was asked to do. I was asked to solve for x. That means I am done. Answer is x equals 7. But the key to that one is, number 1, using our theorem that in similar shapes, sides are proportional. And number 2 is remembering from way back at the beginning of the year how to solve a proportion. And remember, that's when I did this. This is called cross multiplying. When you have two fractions equal to each other, which is what we call a proportion, you multiply the diagonals and set those two things equal to each other to solve.